I'm Anil Kumar sharing with you a test paper on permutations and counting principles. Let me thank all my students for sharing their test papers and letting me make this video. Now the idea here is to understand the concepts. Remember, we haven't learned combination yet, so we'll work with permutations and solve all these questions only using permutations and counting principles. So I have 5 different types of questions here which you can expect in a test paper. Let's go through them one by one. The very first question here is, how many unique 3-letter words can be formed from the word separated if only consonants are used? So if only consonants are used, and we are looking for 3-letter words. Question number 2 is, how many different paths are there to reach 6 blocks south and 5 blocks east while traveling only south or east? So you have to use permutations and counting principles to solve this question. So no Pascal's triangle or no combination rules. Question number 3. How many 3-letter words can be made from the letter in settlements? So these two are separate questions. Separated, we have to do only with consonants, right? Question number 4. 15 balls numbered 1 to 15 are arranged in a triangular form in the game of snooker as shown in the figure. In how many ways can the 15 balls be racked with? So we have different conditions here. So let me just push the page. Let's look into the question. So it says, in how many ways can the 15 balls be racked with no restrictions? That's the first condition. The black ball with the number 15 is not in the center of the third row. So not here, right? So normally we'll place it in the center, but we don't want it here. Only even balls are in the last row, right? So only even balls are in the last row, correct? Now the last question here is question number 5, which is a communication question. It says, students are working with a word puzzle for 4-letter scrambles with the clue word calculate, and they are asked by their teacher, how many of the possible 4-letter scrambles contain 4 different letters? How many of the possible 4-letter scrambles contain 4 different letters? Anna's answer is P94. Fully discuss the validity or invalidity of this answer, right? So concentrate on this answer, which is P94, right? So once again, this is the first test on permutations and counting principles. You are required to apply the rules which you have learned so far. Remember, we haven't learned Pascal's triangle or combination rules by now. So that is the next chapter for us, correct? So you can now pause the video, copy these questions, solve them, and then look into my suggestions. Time allotted for this is 20 minutes. I hope you can easily do it. Thanks and all the best. Now let us try to understand the solutions and also the concepts, how to solve such questions using permutations and counting principles. Question number 1. How many unique 3-letter words can be formed from the word separated if only consonants are used? So we are looking for 3-letter words. So these are the 3 positions to be filled. And we want to use only consonants, which are, so we have S, E is a vowel. So these are the consonants. So let us list these words, letters from the word separated. So these are S, P, R, T, and D. So we have how many of these? So we have 5 of these, right? So we have 1, 2, 3, 4, 5. We want to make 3-letter words. You can see all of them are distinct, no repetitions here. So you have choices. You could put any 5 of them here, right? And then you could put, once you place a letter here, you're left with 4, and then you're left with 3. And therefore, using our counting principles, we get the answer as 5 times 4 times 3, right? Which is 20 times 3 as 60, correct? Now using permutation, you could have answered this Out of 5 permutations, we are looking for 3 positions, right? So NPR formula can be applied, and you can also find this answer using calculator or without calculator, right? So that gives you 6D. Now, a tough question on this will be a variation, which I have mentioned here. How many unique 3-letter words can be formed from the word separated? Now, if I don't separate out the vowels, we have few repetitions, and then there are a lot of words. We are making only 3-letter words with repeated or identical elements. So that makes it slightly more difficult. We have a similar question in our set of videos, which is question number 3. So we'll discuss this later, but it's a good point. You can actually pause and answer and get solution to this question itself. Now, question number 2 here is, how many different paths are there to reach 6 blocks south and 5 blocks east while traveling only south or east? You can actually come across this question in Pascal's triangle and also in the next unit, which is on combinations, correct? So we're looking for 6 blocks south. So 1, 2, 3, 4, 5. So from here, if we start, we go 1, 2, 3, 4, 5. So one more. 6 blocks south, and we are looking for 5 blocks east. So from here, if we start 5 blocks east, so we get 1, 2, 3, 4, and 5, right? So we have reached that place. How many different paths are there to go in this fashion? So how do you solve such a question? Now the idea is that we are starting from this position, landing here. So effectively, you see, we are going 1, 2, 3, 4, 5. So we are going 5 east. And we are going, as we said, 6 blocks south, 6 south. So you can say that there are 11 blocks to be covered. Is it okay? 11 blocks where 5 are identical and 6 are identical, right? So 5 are identical and 6 are identical. And we are looking for different permutations to get an idea, correct? So that is how we could actually think about this question. And once we have done that part, now it's very simple. So we have 11p, and we have to move. So that is 11 factorial, right? So 11p11 we can write there, out of which 5 are identical. That means 5 factorial, that is to divide by 6 factorial. You get an idea, right? So these are the total number of ways in which we can actually reach from this point to that point. Does it make sense to you? Correct? So that is how we could actually answer this question. And now let's calculate. So what we have here is 11p11, right? So that gives a very big number. We'll divide this by 5 factorial, and whatever we get, we are going to divide this by let me just divide this by 6 factorial. So we get 462 paths, right? So we get 462 paths. So that is how it could be done, right? You will learn in Pascal's triangle and combination also how to solve such a question. But here is a very neat approach to solve such a question. I hope that helps. So go through this solution, try to understand the concept, and then we'll move forward. Now here is question number 3. How many 3-letter words can be formed from the letters in settlements? So in this case, we have to make only 3-letter words. And we have all the letters in settlements. So let's first understand what do we have. How many S we have? Let's write down. So let's check 1, 2. So we have 2 S's. Let's write 2S. How many E's we have? 1, 2, and 3. So we have 3 number of E's. T, 1, 2, and 3. So 3 T's also. Okay. The rest of the words are all single. So we'll say 1 for L, that is 1, 2, 3. So these 3 words are single, which are L, M, and N. Correct? Let's count the words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we are looking for total 11 letters. Correct? We have to fill in 3 positions. Out of these, 1, 2, 3, 4, 5, 2 of S, 6, 7, 8, 9, 10, 11. That makes it perfect. 11. So we have not missed any letter. First part is in the test, check all your letters, I should say, numbers should match, right? Now, let's look into how many 3-letter words can be formed from these letters, correct? So, such questions should be done using cases. So, we'll do case 1, where all are unique, right? So, no repetition, right? So, we say distinct, or we'll say distinct or unique, right? All are unique, no repetitions, right? So if that is the case, in that case, what letters should I choose from this list? I will not be choosing 2 S's. So in that case, my list will consist of L, M, N, S, and E and T, right? Just one of each kind. So if I have to fill in 3 spaces with these many letters, which are 1, 2, 3, 4, 5, 6, then how many permutations are possible? That is how you have to think and write your answer. Do you get the idea, right? So for case 1, we are looking for 1, 2, 3, 4, 5, 6. And from there, we have to select 3 positions. Does it make sense to you, right? So that is how we have to do. So case 1 is clear. Now let's do case 2. Case 2 will take 1 double. Well, there are 3 spaces, only 1 could be double. That means a letter could be repeated, right? So if I'm talking about 1 double, then definitely I have LMN. They are single. Okay, no problem. LMN. Now if I use S as my double, then I have 2 S's. So E and T cannot be double, so they are single. So we have this combination of letters to work with. You get an idea, right? So we have this combination of letters to work with. And we have only 3 spaces to fill. Correct? So if I use 2 S's, so let's look into it. Try to understand this particular situation. It's very critical to understand. So we have 2 S's, right? And all other letters are 1, 2, 3, 4, 5. So 5 other letters. So that means if I fix S first, so you have to fix S's first. Correct? That is, you are fixing 2 of these in 3 positions. Perfect? 2 of these in 3 positions. So what do you get? So 2 of these in 3 positions means, let me write, you will use 3P and 2 of these. But both of them are same, identical. So we divide by 2 factorial. Does it make sense to you? Correct? So let us say we have fixed them. Let's say these are the positions fixed. Now only 1 position is vacant. How many can go in that position? So in this vacant position, what we observe is that we have 1, 2, 3, 4, 5. Right? So we'll multiply this by 5. Any one of these could fill in the remaining position. Do you think? So for all the permutations of these 2 S's, we have 5 other things to be placed. Does make sense to you, right? So we'll get this number with 2 S's. Now we have other options also. What are the other options? Well, instead of 2 S's, we could have 2 E's or 2 T's, right? So what I'm trying to say here is we could have L, M, N, 2 T's, right? And then E and S, or we could have 2 E's. We could have L, M, N, E, and then TS. Do you see that? And exactly same rules will follow. So for this particular combination, we have 3 other options. Do you see that? So we get our rule. So that is the answer. So let's figure this out. So we have 3P2 which is 3 times 2, 6. Anyway, let me do it here. It's easier to work with numbers here. So it is, you can say 3p2, that means 3 times 2. Divide by 2 factorial is 2 times 5 times 3, correct? So this cancels. So what do you get? 3 times 5, 15 times 3, 45. So you get 45 here cases. You understand how we got it? This is the most critical part. Okay, now let's move on and we'll do case 3. What could be case 3? Tell me. Case 3 could be, can we have 2 doubles? No, there are 3 places, but we can have a triple. So 1 triple. 1 triple is possible, and as far as the triples are concerned, we have only 2 combinations, correct? Triple E, or we could have triple T. Do you see that? So for this triples, we have 2 options, correct? So these are all the combinations we have. We can find what 6p3 is. It is 6 times 5 times 4, correct? So that is equals to 120, right? 6 times 4 is 20 to 120, correct? So now we get our answer. Our answer is we have to add all these. Is it okay? Does it make sense to you? So the answer is, how many 3-letter words can we have? We could have 120 plus 45 plus 2, correct? So that is the answer. 5 plus 2, 7, and 4 plus 2, 6. 167 are the total number of letters which we can have. So I hope this is absolutely clear. So I'd like you to really understand this concept and then go back and do part 1b, right, which we left. That will be very helpful to you. So let's move on and do question number 4 now. Here is another very interesting example. Question number 4. 15 balls numbered 1 to 15 are arranged in a triangular form in the game of snooker as shown in the figure. In how many ways can the 15 balls be racked with A, no restriction, right? So any ball can be placed anywhere. B, the black ball with number 15 is not in the center of third row. So I'm showing it right there in the center, but how many ways can you make this arrangement so that this is not here? That's the question, okay? C, only even balls are in the last row, right? So we have only even number of balls in the last row. You can actually pause the video, answer this question, and then look into my suggestions. Now the first one is we have 15 balls and all 15 have to be arranged, so that should be straightforward. So we have 15p15 as the combination. You could write this as 15 factorial, correct? Part B is the black ball with number 15 is not in the center. Okay, so in this case, we can apply the counting principle of indirect method. So I'm going to use indirect method here. So in that, what do we do? We'll say, we'll place it in the center. So we'll do 1 minus in center. Does it make sense, right? In center. So we'll find number of ways in which it can be placed in center. And then if we take away, 15 factorial, I should write not 1, all I should write here. All ways minus in center ways. Is that okay? It does make sense to you. Okay. So this is A option, which is all without restriction. And then we make a restriction that this is indeed at the center. Then how many? Okay. So if I fix this, then we are left with 14 balls and 14 positions. So that is 14p14. Is that okay? And therefore, the answer for this will be 15 factorial take away 14 factorial. Does it make sense to you? Correct? So what I'm trying to say here is, with no restriction, we get 15 factorial ways. And if I fix this position, I'm left with 14 balls and 14 positions. So that is equal to 14 factorial ways. But what do we want? We do not want black ball right here. So number of ways will be difference of these two, right? So it is 15 factorial minus 14 factorial. Perfect? Okay. Now let's do the last one, which is very tricky. Only even number of balls in the last row. So we want numbers like 2, 4, 6, 8, maybe 10. All right. So there are other numbers also, which are like 12 and 14, right? So those are the even numbers. So what do we have here? We have 7 even numbers. You get an idea, right? So we have 7 even numbers, and out of them 5 can be placed in the last row, correct? So let's fix this first. So we'll start with the last row. We want all even. That means we get the combination out of 7. Out of 7, we have how many ways to do it? 5. Does make sense to you, right? So we did this. Now out of 7 we fixed 5. Okay, so we have fixed 5. We are left with 2 even. So 2 even left in other positions. So that is the way I'm thinking and sharing with you. So we have already placed 5 here. Okay, we are left with any 2. We don't know which 2, but any 2. So they have to be placed in rest of the positions. So total are 15, correct? So that means what? That means that we are left with how many positions? 10 positions, correct? So in 10 positions, so these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So in 10 positions, we have to fix these 2. So that gives you 10p2. Perfect. 10p2. Okay, good job. So that is the second step for us. Now what is left? There are total 15. We are left with 8 odd number balls. Is that okay? And how many positions? In how many positions? So we have already fixed 5 plus 2, 7. So in 8 positions. So what do we write here for 8 positions? 8 odd number of balls. It is 8p8. Perfect. So that is what it is. Now they should be multiplied using the counting principles. So we get our answer now. So our answer is 7p5 times 10p2 times 8p8. Does it make sense to you? Right? So let's do this. It should be a big number. Let's figure it out. 7p5 times 10p2 times 8p8. 8p8. And that gives you a huge number here. Okay, let's multiply and write down this number, which is 9,144,576,000. Oh my God. So that is the number of ways. You get an idea, correct? So it's a big number, but let's figure out what is the answer for the first one. 15 factorial. Let's see how big that is. That's huge, right? So we get this number as 1.30 something times 10 to the power of 12. So we are working really with a lot of combinations here. Now let me figure out the next one. So we'll take away 14 factorial. So we get 1.22. So which is, let me write here, 1.22 into 10 to the power of 12. Correct? So that will give you an idea of the answers. 15 factorial is around 1.3 times 10 to the power of 12. This is 1.2 times 10 to the power of 12 when the black ball is not in the center, correct? And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positions here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9.1 into 10 to the power of 9 will be this answer. So that is how you could do it. So I think the concept is clear. Go through it once again. Now these are very important questions for your test on permutations and counting principles. We already have a list of practice test questions. I'd like you to go through them just to ensure 100% in your test, right? So let's move on and do the last question now. Question number 5. Students are working with the word puzzle for 4-letter scrambles with the clue word calculate, and they are asked by their teacher, How many of the possible 4-letter scrambles contain 4 different letters? Anna's answer is P94. Fully discuss the validity or invalidity of this question. Now, this is a communication question. You should provide complete reasoning for your answer, right? So first thing is this the correct option? I mean, is this the correct answer? Okay, so let's look into the word first. We're looking for calculate, that's the key word. What do you think should be the answer? Okay, I hope you have got it right. We are looking for calculate, and the key word here is distinct, right? So how many of the possible 4-letter scrambles contain 4 different letters? So we're looking for 4-letter combination. Is it okay? So let's see how many letters are there in calculate, right? So C, so we have 1, 2, 3. C's we have already taken. 4, L we have already taken, A we have already taken, 5 and 6. So basically you will observe that there are 6 unique letters, right? So we have 6 unique, or you can say distinct letters, which are C, A, L, U, T and E. Do you see that? So if you have to make these combinations, the answer should be 6, 5, 4, 3 or what? Or it should be 6, P4, correct? Which could be written in different ways. As you can see, we could write this as P64. So there are different ways in which we are using the symbol. You could also write 6P4, correct? So any nomenclature can be used, but that is the answer, correct? So, and you can easily explain this, saying that we have a choice of picking from actually only 6 letters, distinct letters, and there are 4 positions to be filled. And using counting principles or by permutation, the answer should be 6 times 5 times 4 times 3 or 6P4. I hope that makes sense. Feel free to write your suggestions and views, and also if this type of an exercise is worthwhile for a good review, right? We'll take up the next test on counting principles with combinations and permutations combined. So that'll be very interesting. Some of these questions could be solved easily using combinations. I agree with you. But I hope this helps. Thanks for watching and all the best for your test.